minute. Yeah.
Good evening, all. It's today's topic. INA's topic is maritime autonomous surface ships. This is a very current topic, and in this webinar, we are exploring the evolution and significance of MaaS in the maritime industry. It will cover the historical progression of ship automation, definition and differentiation of MaaS, and the role of international regulations in shaping the development. Yeah. With this session, we have got this session where we have got the presenters, Mr. Bhagat Singh Geda and Mr. Sandeep Kumar, and the session is chaired by Dr. Manu Korulla. This will be followed by a panel discussion with panelists who cover the entire spectrum of industry, operators, and seafarers. With this, it's my privilege to introduce the session chair for the day, Dr. Manu Korulla. Dr. Manu Korulla is an outstanding scientist at DRDO, and is currently the Director of Management Services and Director of Works and Estates at DRDO. He has a BTech degree in Naval Architecture and Shipbuilding from Cochin University of Science and Technology, an MS degree in Naval Architecture and Ocean Engineering, as well as a PhD in Hydrodynamics from Indian Institute of Technology, Kharagpur. He also has an international PG diploma in Project Management from I2P2M and George Washington University, USA. After a 4-year tenure at Garden Reach Shipbuilders and Engineers, Kolkata, a public sector shipyard, he joined the Defense Research and Development Organization at their hydrodynamic research facility at the Naval Science and Technological Laboratory at Visakhapatnam as a scientist. During his long tenure at NSTL, he was Associate Director, Technology Director for Hydrodynamic Research, and Project Director for the Development of Autonomous Underwater Vehicles. His total experience is 35 years and has headed several project assignments relating to design and development of marine vehicle systems and robotic vehicles. This includes development of advanced marine crafts, multi-hull ships, submersibles, autonomous underwater vehicle, and underwater weapons. He was conferred the Scientist of the Year 2017 for his outstanding contribution in naval research and development. We welcome the session chair, and now we hand over the session to the session chair, please.
To Dr. Bharadwaj.
Yes.
Now we have yet another technical session. It's technical session 6 in 2023. That's quite a good achievement. We have covered 6 months, and every month we had technical session. I take this opportunity to congratulate Dasgupta sir and Technical Secretary Dr. Bharadwaj, and of course Mr. Amit Ahmed, who is the backbone for making it all happen. Today, I welcome our speakers, Mr. Bhagat Singh Geda and Commander Sandeep Kumar. Then our panelists, Dr. R Chary, former Executive Director of ECI, Captain Ramji Krishnan, former Director and CEO of Mundra International Container Terminal Private Limited, Mr. Anish, Deputy General Manager of Cochin Shipyard Limited. So you can see the number of naval architects and professionals have joined for this session. A number of them have contacted me. I welcome all of you for this today's session on maritime autonomous surface ships. At the outset, we are remembering, today Mr. R Sawarkar, and we were hoping that we'll have a small remembrance session, which we can have just after introducing the speakers. Is it so, Dr. Bharadwaj? Can we go ahead?
Yes, yes, so we can go ahead, sir. I'm waiting for Mr. Govil to join,
Okay.
who is very close associate of Mr. Sawarkar. As he joins, we will just time the remembrance session, so we can go ahead with the session.
Yeah. With that, let me first introduce Mr. Bhagat Singh P. Geda, today's speaker. Mr. Bhagat Singh P. Geda is an alumnus of IIT Madras. He has done BTech in Naval Architecture and Ocean Engineering. He has had the opportunity to work in both public and private sector shipyards, gaining valuable field experience. Since 2013, he has been a part of the IRS Rule Development Department, contributing to various important projects. Additionally, Mr. Geda was a member of the ISES Task Force on MASS, MASS, for the purpose of regulatory scoping exercise and is currently a member of the ISES Expert Group on MASS and ISES representative to IMO on MASS related matters. Through these experiences, he continued to learn and grow, contributing his knowledge to the maritime industry. Commander Sandeep Kumar is joining him in presenting. Commander Sandeep Kumar, retired, is an alumnus of both Cochin University of Science and Technology and IIT Delhi. He completed his BTech in Naval Architecture and Shipbuilding from Department of Ship Technology, Cochin University of Science and Technology, Kochi, and post-graduation thereafter from the Indian Institute of Technology, Delhi. He has more than 2 decades of rich and varied experience in ship design, overseeing of new construction, ship repairs, and policy matters. At IRS, he is currently working with the Rule Development Department. Now, shall we start with the presentation? And once the presentation is over, prior to our panel discussion, we'll have the memorial for memorial talk on Mr. BP Sawarkar. Is it okay, Dr. Bharadwaj?
Yes, it's okay, sir. We can start the presentations with your permission.
So let me request Commander Sandeep Kumar to start the presentation, followed by Mr. Bhagat, Mr. Geda. We have this session for together 40 minutes. Because we have many things in the agenda, I request both of you to keep the timing. Shall we start?
Yes, sir.
Yeah, please come.
Am I audible, sir?
Yeah.
Yes.
So we'll start, sir. A very good afternoon to you all, ladies and gentlemen, who have tuned into this webinar. At the outset, we would like to convey our deep gratitude to the Institution of Naval Architects for inviting us to speak at this webinar, and we are truly humbled by this gesture. As you can all see the topic for today's talk on the screen, it is Maritime Autonomous Surface Ships, MASS, Navigating the Future. Coincidentally, the IMO has also selected a similar headline, that is Navigating the Future, Safety First, as the World Maritime theme for 2024. And 2024 also marks 50 years since the adoption of the 1974 SOLAS Convention. In our understanding, the topic of MASS has far-reaching implications for the maritime industry today as we know it. Our industry is embracing technology very fast, and sometimes it is becoming difficult for regulators and regulations to keep up with the pace of developing technologies. Even as we speak about MASS, we must be cognizant of 2 aspects. One, the human factor or the human element, which always ought to be in control of the MASS, and 2, the underlying safety considerations. Our presentation today will give the audience an overview on the evolution of automation in the maritime industry, the definitions, levels, degrees of autonomies of MASS, the evolution of regulations pertaining to MASS, especially the development of the MASS code, both the non-mandatory code and the mandatory code, various aspects to be taken care of whilst developing a MASS. We'll also have a brief look at the IRS initiatives with respect to maritime autonomous surface ships, challenges and opportunities for stakeholders when we speak of MASS. We hope that the presentation would be useful in simplifying MASS to the wider audience and would serve as food for thought as we move into the panel discussion afterwards, especially with noted experts in their fields. With that, I would request Mr. Bhagat, my colleague, to carry on with the presentation. Thank you.
Thank you, Commander Sandeep. Ladies and gentlemen, esteemed participants of the webinar, a warm welcome to each one of you. I'm here before you today to delve into the fascinating world of maritime autonomous surface ships, or MAS. In next 40 minutes, we shall explore how it is shaping the future of maritime industry. Automation in the maritime industry dates back to early 20th century, when basic mechanical systems eased manual labor. Advancement in navigation and communication, along with concept of unattended machinery space, further revolutionized the industry. Today, sophisticated technologies such as integrated bridge system, dynamic positioning, and others have significantly improved safety and operational efficiency. Now, let us focus on defining the characteristics of MAS. MAS, or Maritime Autonomous Surface Ship, refer to vessels capable of operating without direct or with very limited human intervention. They use a combination of advanced technology, including sensors, communication systems, and artificial intelligence to perform their task autonomously. Levels of autonomy for MAS range from ships with automated processes to fully autonomous ships. They operate at different levels of autonomy, ranging from level 1, where the computer system supports the operator's decision, to level 5, where the system takes full charge but allows human intervention during emergencies. Each level entails increasing degree of automation and decreasing human control. MAS promises several advantages, including enhanced safety, increased efficiency, and cost reduction, making it a transformative force in the maritime industry. Now, let us turn our attention to evolving regulations that will shape the future of MAS. International Maritime Organization, IMO, has been actively involved in developing regulations to ensure safe and efficient integration of MAS into global maritime industry. In May 2021, the IMO's MSC, Maritime Safety Committee, completed a regulatory scoping exercise to analyze relevant IMO instruments such as SOLAS, OLREG, Load Line Convention, STCW Convention, and more. The objective was to assess how MAS could be effectively regulated. 4 degrees of autonomy were assumed, as it can be seen on this slide. I must emphasize that these degrees of autonomy are only for the purpose of scoping exercise. These are not prescribed for doing design. This exercise aimed at assessing the existing regulations against the MAS application check questions, which can be seen on the right side of the slide. These are the 4 questions which were asked for each regulation and were tried to answer. So the idea was that 4 degrees of autonomy to be checked against this question and come up with possible way ahead. The possible way ahead could be developing interpretations to the existing regulation, or amending the existing regulation, or making new IMO instrument, or do nothing when there is no effect of MAS on that regulation. Similar exercise was done by LEG committee, which is legal committee of IMO, and FAL committee of IMO as well, for the IMO instruments coming under their domain. So basically 3 IMO committees did the regulatory scoping exercise: MSC, LEG, and FAL. A joint working group has been established between MSC, LEG, and FAL to address the common concerns between these 3 committees. Now let us discuss the development of goal-based MAS instrument, which has emerged as a key approach in regulating MAS operations. To address the regulation of MAS comprehensively, IMO proposed the development of goal-based MAS instrument in form of a MAS code. This code would outline specific goals, functional requirements, and corresponding regulations suitable for all levels of autonomy. By adopting a goal-based approach, the code focuses on achieving performance objectives rather than prescribing specific technologies and design solutions, being a technology neutral. This flexibility allows for innovative approaches while maintaining a strong focus on safety. Here is an overview of the structure of MAS. It is proposed to be divided into 3 parts. The first part will outline fundamental principles, purpose, and objectives. It will also cover the overall code structure, application areas, and important terminology and definition. Part 2 will address the operational context and define the high-level functional requirements. These requirements are crucial in ensuring the safe operation of MAS. Part 3 is a comprehensive part that covers specific goals, functional requirements, and provisions related to various aspects of autonomous ship operation. Currently, 14 sections are planned for this part, as shown in the slide, covering topics like navigation, remote operations, and more. The draft MAS code is a critical step in ensuring the safe and responsible integration of autonomous ships into the global maritime industry. Now, let's explore the timeline for development and implementation of the MAS code. Currently, work is in progress at IMO to develop a non-mandatory MAS code. By December 2024, it is expected that non-mandatory MAS code will be finalized and officially adopted. This code will lay the groundwork for subsequent mandatory code. Following the adoption of non-mandatory code, the development of mandatory code will commence. This will be a more comprehensive and binding set of regulations. Finalizing and approving of mandatory MAS code is expected to be completed in the first half of 2025. Finally, the new mandatory MAS code will be adopted in the first half of 2026 and will be officially entering into force on 1st January 2028. From this date onwards, all MAS operations must comply with the mandatory code. As we approach these milestones, collaboration between regulatory bodies, classification societies, industry stakeholders, and technology developers will be crucial. Now that we have a clearer understanding of the regulations shaping the future of MAS, let us explore the key components involved in developing a successful MAS system. Creating a successful MAS system requires careful consideration and integration of several essential components. Let us look at few key ingredients to make up this recipe of success. The core intelligence of a MAS is Autonomous Navigation System, also known as ANS. It is responsible for safe and efficient navigation. It utilizes a network of sensors to detect and integrate data about the ship's surrounding. To ensure safe and effective operations, it is crucial to define operational design domain, which is also known as ODD. Human-machine interface serves as a critical link between ANS and the crews or operators. Remote monitoring and control capabilities enable external entities to oversee MAS operations from a distance. Extensive testing and validations are essential to ensure reliability, safety, and effectiveness. In the subsequent slides, we will discuss in detail about all these aspects. The Autonomous Navigation System, or ANS, is the very essence of safe and efficient navigation. It includes 3 vital functions that work seamlessly in harmony to ensure smooth and reliable operations. First and foremost, we have situation awareness. Picture a network of advanced sensors, radar, LiDAR, cameras, etc. surrounding the ship. They continuously gather and integrate data about ship surrounding. This constant awareness is the cornerstone of informed decision-making, enabling the ANS to navigate with precision and foresight. Next comes decision for collision avoidance. Armed with the wealth of data collected through situation awareness, the ANS acts as a strategist. It meticulously analyzes potential collision risks and devises intelligent collision avoidance strategies. This proactive approach to collision avoidance is fundamental to preventing potential accidents and ensuring smooth operations in MAS. Finally, we have action. ANS is not just a thinker, it is also an executor. After making informed decision, it springs into action, actively controlling the ship's movement. This dynamic response to potential collision ensures that vessel remains on the path of safety. ANS can be imagined as a captain of the ship, constantly vigilant, assessing the surroundings, making wise choices, and steering the vessel confidently on its course. Sensors serve as eyes and ears of Mars. Autonomous ship will rely on various types of sensors that will work together to create a comprehensive situational awareness. Visual sensors like cameras capture visual information from vessels surrounding. Remote sensing sensors such as ship radar provide critical data for long-range detection and accurate distance measurement. Audio sensors comprises of microphones and hydrophones. Localization systems, including GNSS, ECDIS, offer precise positioning and navigation information for vessels' route planning and execution. Apart from this, there will be weather sensors and sensors inside the ship monitoring its machinery's performance. Due to limited time in this talk, we will mainly focus on navigation. Some key properties which should be considered while deciding on navigation sensors are spatial accuracy, field of view, distance measurement capability, all-weather capability, computational load, and more. These are some of many properties which should be considered while designing a sensor system. Some sensors are very good in one property while not so good in other. For example, cameras have limited field of view, typically capturing narrow view of surroundings, while radar has a wide field of view, covering a broad area around the vessel. Therefore, convolution of data from sensors is very important and makes the sensor deployment strategy a very crucial part. As a very basic example of sensor deployment strategy, detection zones can be divided into long range, for example, 1 nautical mile and above, and close range, which is below 1 nautical mile. Long range sensors such as AIS, radar, and stereo cameras provide critical data for distant object detections and verification. Close range sensors, including LiDAR and microphones, can be crucial for detecting objects in proximity. As a processing strategy, data fusion and integration will be a vital process and will combine information from various sensors to create a comprehensive situational awareness picture based on convolution. Advanced artificial intelligence technique, particularly image and sound processing, will enable detection and identification of object in data snapshots from various sensors. AI-driven analysis enhances real-time processing and decision-making. In conclusion, sensors are the backbone of autonomous ships. As we continue to advance in technology, these sensors will evolve further. Now let us explore some of the key collision avoidance strategies employed in Mars. By leveraging historical data and real-time information, ANS can accurately assess potential threats and take proactive measures to avoid collisions. ANS is equipped with sophisticated algorithms that calculate the safest and most efficient route. Route optimization takes into account various factors, including weather condition, traffic density, and navigational hazards. Unforeseen situations can arise even in the most meticulously planned voyages. To address such contingency, the ANS is designed with comprehensive emergency procedures. In the event of an imminent collision or hazardous scenario, the system can swiftly initiate emergency stops or execute evasive maneuvers. This rapid response capability allows the autonomous ship to effectively navigate through critical situations. Fusion of these collision avoidance strategies empowers Mars to operate with safety and efficiency. Now, let's explore a few algorithms which can be used for collision avoidance. Velocity obstacle algorithm is a widely used approach for collision avoidance. It assesses potential collisions based on relative velocities and positions of nearby vessels. It computes the velocity obstacle array for each neighboring vessel, representing unsafe velocity ranges that might lead to collisions. Reciprocal collision avoidance, RCA, is a rule-based approach for collision avoidance. It defines priority rules for interactions between vessels and maneuvers to avoid collisions. RCA algorithms follow predefined priority schemes and apply the appropriate avoidance action based on vessel's role, such as give way or stand on. RCA can ensure compliance with regulations such as cold reg and traditional navigation practices. Similarly, there are various algorithms such as artificial potential field, which creates an artificial potential around the vessel and the neighboring vessel. There is a model predictive control algorithm and machine learning techniques which are continuously evolving. This is an evolving field of research, and for sure, more of this will come in future. To ensure safe and effective operation, it is essential to define operational design domain, ODD. It specifies the condition and limits within which ANS can operate. It comprises various elements that contribute to defining the scope of mass operations. ODD specifies geographic area in which mass can operate, such as open sea, inland waterways, or specific coastal regions. ODD may also include restriction on certain areas due to environmental consideration and navigational challenges. ODD must account for varying weather conditions, such as high winds, heavy rain, fog, rough seas, to ensure safe navigation. As an example, a mast may have an ODD limiting to operate within 200 nautical miles from shore, in sea state up to Beaufort 5, and without ice or heavy fog conditions. Defining ODD is a critical step in ensuring the safe and efficient deployment of any autonomous ship. Remote monitoring and control capabilities are essential features of MAS. They enable external entities such as shore-based operators and authorities to oversee MAS operations from a distance. It offers several advantages, such as it allows continuous supervision and assessment of ship's performance, adherence to its ODD, and compliance with regulation and protocols. In case of emergencies or unforeseen situations, remote operators can intervene and take control of ship remotely. This ability to provide remote assistance enhances safety and mitigates potential risk. To ensure the security of remote monitoring and control, robust cybersecurity measures are very essential. These measures provide safeguard against potential unauthorized access or cyber attacks that could compromise vessel safety and operational integrity. Human-machine interface is a critical link between ANS and the crew or operators. It serves to facilitate effective communication, situational awareness, and intervention when necessary. Key features of human-machine interface include provision of a comprehensive display of real-time data, including position, surrounding vessels, weather criteria, ANS status, and the status of critical internal machinery such as engines and thrusters. This real-time monitoring allows the crew or operator to stay informed about ship's operational status. Human-machine interface issues timely alerts when potential risks are detected, be it outside the ship or inside the ship. This feature provides the crew with crucial information, allowing them to take appropriate actions to avoid any potential hazard. The Remote Control Center, also known as ROC, should be designed considering the human-machine interface. In the next slide, we will discuss more about ROC. The Remote Operations Center takes into account consideration of human-machine interface. It serves as a nerve center for overseeing single or multiple mass operations simultaneously. It integrates real-time data from various sensors, communication networks, and autonomous vessels, providing operators with a holistic view of the fleet's status and performance. ROC plays a pivotal role in efficient decision-making and resource allocation. Key aspects of ROC include a well-designed user interface with intuitive display, clear visualization of vessel data, and user-friendly controls to efficiently manage and respond to varying operational scenarios. It should be equipped with advanced data integration and analytics capability to support data-driven decision-making. It should be designed with redundancy and fail-safe mechanism to ensure continuous monitoring and control, even in the event of system failures or network disruptions. It should have a secure communication network. Implementing encryption protocols and strong authentication measures are very important. Extensive testing and validation form the backbone of ensuring the safety and effectiveness of MAS. Real-world scenarios and simulations should be conducted to validate the performance of ANS and the overall MAS system. These rigorous testing and validation processes serve several critical purposes, which I will explain later. Through thorough testing, any limitation or potential challenges that the MAS system may face are identified. This knowledge is invaluable as it allows engineers and developers to make necessary improvements and refinements to systems design. By addressing these limitations early on, the overall performance and safety of MAS can be significantly enhanced. Testing provides valuable data that aids in optimization of collision avoidance algorithm and other essential functions. Rigorous validation builds confidence in the reliability and safety of MAS technology. During the testing phase, the performance of ANS and other subsystems should be thoroughly assessed. As I conclude this topic on the recipe of MAS, it is evident that this technology is indeed complex. Each aspect of MAS requires in-depth exploration and understanding. And even then, there will always be a room of continuous improvement and innovation. Now, I will share some of the initiatives taken by the Indian Register of Shipping in the realm of MAS. At IRS, we have developed guidelines and requirements for both remotely operated vessels and fully autonomous surface vessels. IRS is actively associated with some MAS development projects in India, which are driving innovation and fostering growth of autonomous ship technologies within the country. IRS chairs the Cyber Systems Panel in the International Association of Classification Society. Through this leadership role, we are working diligently to establish robust cybersecurity measures for ship, addressing the unique challenges posed by autonomous systems. IRS actively collaborates with leading classification societies worldwide as a part of IX expert group on MAS. While MAS holds immense potential to revolutionize the shipping industry, they also present stakeholders with unique challenges in adopting it, and it provides opportunities as well. I want to emphasize that the challenges and opportunities discussed in this talk are not exhaustive. They are merely meant to ignite your thought process and encourage further exploration. Our subject matter is intricate and ever evolving, and these insights serve as a starting point for deeper discussions. Having said that, let us explore possible key challenges. Initial investment and integration cost. The transition to MAS will involve upfront cost for acquiring and integrating autonomous technologies on board vessels. Redefining ship design. The shift towards autonomous ship makes it necessary to reevaluate traditional ship design, where accommodating crew space, control room, etc. are important considerations. With the absence or reduction in onboard crew, we may focus on optimizing vessel layout for cargo capacity, energy efficiency, and safety without compromising stability and maneuverability. Communication and connectivity. Seamless and uninterrupted communication between autonomous ship and their control center is essential for effective operations. We must address challenges related to long-range communications, satellite connectivity, and signal interference to guarantee constant data transmission and real-time decision-making. Cybersecurity. As autonomous ships rely heavily on interconnected systems and data exchange, ensuring robust cybersecurity becomes a major concern. We must provide ship with stringent cybersecurity measures to prevent unauthorized access, data breaches, and potential cyber attacks that could compromise safety. Redundancy and safety. In conventional ships, crew members can handle unforeseen situations and emergencies. With autonomy, ship must have redundant systems to ensure continuous operation in case of equipment failure or unforeseen event. We need to consider backup power systems, autonomous emergency response protocols, and advanced safety features to minimize or eliminate risks. Regulatory framework. The transition of autonomous ship requires establishment of new regulations and legal framework. As we discussed earlier regarding the IMO's work on developing mass code, we have to comply with this evolving regulation. Navigating through rapidly changing regulatory landscape can be challenging and requires greater adaptability. Training and workforce. With the introduction of autonomous ships, the workforce dynamic in shipping industry will change significantly. Stakeholders will have to consider training programs to ensure that maritime personnel can effectively operate, maintain, and repair these advanced vessels. The role of onboard crew members may evolve, requiring reskilling to handle the operations, monitoring, and maintenance of autonomous systems. There may be a need to invest in training programs to equip crew members with necessary skills to work alongside autonomous technologies effectively. Liability and insurance. The introduction of autonomous technology raises questions about liability in the event of accidents and collisions involving mass. Determining responsibility between ship owner, operators, manufacturers, and software developers can be challenging. Insurance providers may have to develop new coverage policies and assess the risk associated with autonomous ships. Now that we have seen few challenges, the emergence of mass presents exciting opportunities for stakeholders as well. As the technology advances and gains acceptance, stakeholders may capitalize on new business opportunities and expand their role in the autonomous shipping ecosystem. Let us explore some of these opportunities. Remote control centers. As mass operations becomes more prevalent, there will be a growing demand for remote control centers. Companies can establish remote operation centers for offer of services to multiple vessel operators, optimizing fleet performance and safety. Autonomous vessel design and technology providers. Stakeholders involved in vessel design, engineering, and technology development have a unique opportunity to pioneer and supply cutting-edge autonomous vessel technology. This includes designing autonomous capable vessels with advanced sensor suites, autonomous navigation systems, and robust communication infrastructure. Software solutions. Developers of software and artificial intelligence algorithms play a critical role in enabling autonomous navigation and collision detection. Companies can offer navigation softwares, simulation softwares for testing purpose, route optimization algorithms, collision avoidance system, and advanced AI solutions to enhance vessel autonomy and efficiency. Sensors and communication technology providers. Stakeholders in sensors and communication technology can provide state-of-the-art equipment such as LiDAR, radar, cameras, stereographic cameras, and communication systems specifically tailored to the needs of autonomous vessels. Cybersecurity and data protection services. Companies can offer cybersecurity services specifically tailored for autonomous vessels to safeguard against cyber threats and ensure data protection. Training and certification programs. As autonomous ships evolve, there will be a need for specialized training and certification programs for crew members and shore-based personnel, and also operators at remote control centers. Stakeholders can develop and offer training courses to equip individuals with the skills required to operate, monitor, and maintain autonomous vessels. Data analytics and predictive maintenance. Analyzing data collected from Mars can provide valuable insights for optimizing vessels' performance, maintaining schedule and fuel efficiency. Stakeholders can offer data analytics and predictive maintenance services to help ship owner optimize their operations and reduce downtime. In embracing these opportunities and overcoming the challenges, we can shape the future of autonomous shipping. Will provide us with invaluable insights into the latest advancements in autonomous technology. These collaborations foster innovation and enable us to create cutting-edge vessel design that push the boundaries of what is possible. Together, let us embark on the journey of transformation. Thank you all for your attention. Thank you.
Thank you. Thank you. That has been wonderful. You have kept the time. And I really appreciate that. Now, though I would like to give my comments on the topic, we have a small brief session on the remembrance of our Sawarkar sir. Dasgupta sir also has joined, and as I understand.
Thank you, sir. We will have a short remembrance
Mr.
session.
Pierre Govil sir. Right. I request Bharat Srinivas
Yes,
to
yes, sir. Yes, sir. Yes, sir.
have the
Yes.
remembrance session conducted. Yeah.
Yes, yes. We would like to have a remembrance session on Mr. R Sawarkar. I invite Mr. Pierre Govil, who has been his colleague for quite some time, to speak on Mr. Sawarkar. Govil, sir, please. Mr. Govil, you can just unmute and speak on Mr. Sawarkar, please. Yes, yes. Please, sir.
I can't hear.
Sir, you're audible, sir. You can please speak on Mr. Sawarkar, sir. Sir, you're audible, sir. You can speak on Mr. Sawarkar, sir.
Govil sir, this is Dasgupta here. Can you hear me, sir? Can you hear me, sir?
No, I can hear you. My voice is very low. Can you hear me?
Yes, we can hear you well. Can you please say a few words about Mr. Savarkar, who was your batchmate?
Okay. Ms. Sawarkar was my batchmate and very good friend of mine.
Yes, sir.
He was very good in, he was sort of all-rounder, very good in studies and sports as well. So he was, very good in class, and he could easily make the friends. So actually we are together in there in IIT, then in coaching shipyard also. And even after that, we had a regular contacts. So I can't say much about him, but you know, he was very good, my friend. I lost him very bad. Yeah, thank you.
Thank you, sir. Is there anybody from the audience who would remember Mr. Savarkar and say a few words?
So you can, yeah, I think we have few raised hand from the audience, so we can add them. 1 second. I'll just add Mr. 1 second. Yeah, so I've added Mr. Simon into the panel. Yeah, Mr. Simon, you can.
Good evening, everybody. I am Dr. K. A. Simon, a retired director from Cochin University School of Marine Engineering. I knew Mr. Sawarkar very well when he was working for Cochin Shipyard as the chief general manager, if I'm not mistaken. And he was subsequently technical director. At that time, I happened to be the surveyor in charge and shipping master in MMD Cochin. I have had the good fortune of interacting with him on several occasions. I really miss him, and I convey my condolence in his sudden departure. Thank you all.
Thank you, sir. Thank you very much. Amir, if there is nobody else, we can possibly go back to the session.
Sure, sir. Right now, I think I'm not seeing any raised hand. So yeah, we can continue, sir. Yeah.
Yes, sir.
Thank you.
If we can, some 10 seconds, we'll have silence in
Yes.
remembrance of Mr. R Sawarkar. Keep 10 seconds silence. Yeah, thank you. If all of you are with me, we would like to start the panel discussion. We had now a very good presentation on maritime autonomous surface ships, MAS, navigating the future. This was from Commander Sandeep Kumar and Bhagat Singh Geda. We will reserve the question and answers for the panelists to talk first. We will be taking up questions and answers after the brief panel discussion. We have today as panelist Dr. R Chary, former Executive Director of Shipping Corporation of India, Captain Ramji Krishnan, former Director and CEO of Mundra International Container Terminal Private Limited, and Mr. Anish, Deputy General Manager at Cochin Shipyard Limited. Actually, Dr. R Chary will be giving us as an operator, how he looks at the whole scenario of maritime autonomy surface ships entry into the scenario. I would like to introduce Dr. R Chary. Dr. R Chary, who is a marine electrical engineer by profession, took his bachelor's degree in electrical engineering, master's degree in industrial electronics and control engineering, and doctorate in control engineering and automation from the VJTI University of Mumbai. His PhD thesis was on a system for nuclear reactor power controller for nuclear power ships and adaptive autopilot and guidance system for ships. Very apt research area for today's topic. Dr. Chary did a senior management program at Henley, UK on a Government of India fellowship under the Colombo Plan program. He worked with the Tata Electric Company as a design and development engineer before joining the Shipping Corporation of India in 1974. Dr. Chary has over 3.5 decades of wide-ranging experience in the technical, commercial, and IT areas of the shipping industry. He has held senior positions of Executive Director, Group General Manager of Shipping Corporation of India. He has done consultancy assignments on behalf of SCI for the ONGC, the Department of Ocean Development, and the Geological Survey of India. Dr. Chary has, to his credit, over 30 research publications in various international as well as Indian technical and management journals, and has presented papers at various conferences worldwide. Dr. Chary has authored 2 books in management science titled Corporate Transformation Without Tears and Digitalization of Business Process, a Systems Approach, respectively. In 1979, he was the chairman of the International Ship Operation Automation Conference held in Tokyo, Japan. He is a recipient of the Achievement Award presented by the Institute of Electrical and Electronics Engineers, IEEE, USA, for original work in 1974. A special award given by the Institution of Engineers India for outstanding contribution in 1975. And the H.S. Rao Memorial Award given by the Institute of Marine Engineers India in 1993, 2011, and 2013 for his work on harnessing renewable energy for generating electricity at sea. As a visiting faculty member, Dr. Chary has guided postgraduate research students in the Faculty of Electrical Engineering of the University of Bombay. Dr. Chary has been a member of the Advisory Technical Committee of the Lloyd's Register of Shipping, London, chairman of the Ships Electrical Equipment Standardization Committee of the Bureau of Standards, and a member of the Project Review and Steering Group of the Department of Electronics, the Department of Ocean Development, and the Department of Science and Technology of Government of India. Dr. Chary is a member of the Institution of Engineers and the Institution of Marine Technologists and a fellow of the Institute of Marine Engineers, India. He was a member of the Tamil Nadu Maritime Board and a trustee of the Madras Port Trust. He has been a member of the Research and Recognition Committee of the University of Mumbai and a distinguished professor and PhD guide of the Amit University, Chennai. At present, Dr. Chary is an independent maritime consultant. As an academician, he is an adjunct professor and a guide of the Indian Maritime University, Chennai. He is also a member of the Senate of the Manipur Central University, Imphal. We are lucky to have Dr. Chary with us today. I request Dr. Chary to give an opening remarks for the panel discussion. Thereafter, I'll be introducing Captain Ramji. We'll hear from him, and then I'll introduce Mr. Anish. So I request Dr. Chary to come in. Dr. Chary, please. Dr. Chary, am I audible?
Yeah, Dr. Korulla, we are able to hear you. Dr. Chary, your voice is not reaching us here.
Dr. Chary, we are not able to listen to you.
Seeing that Dr. Ramji Krishna has raised his hand. Captain Ramji Krishna has raised his hand, sir.
No, I didn't. I'm sorry.
Yeah,
I'm sorry, I made a mistake. Sorry.
Yes.
Okay. In the meanwhile, by the time Dr. Chary make the audio clear, I would like to introduce Dr. Captain Ramji Krishnan. Dr. Ramji Krishnan is another panel member for us today. Captain Ramji Krishnan has worked extensively in Europe for over 10 years and then in Africa, UAE, and later on in India in various senior level positions, including as CEO, director of a container terminal in Mundra, and later at Tutti.
Hello, sir. Hello, sir. Yes, sir.
He holds a master's degree in management from London Business School and is a Sloan Fellow. He is a master mariner and has completed the course requirement for extra masters and MPhil in system dynamics from University of Bergen, Norway. In the recent past, he was involved in manufacturing and using automated watercraft for hydrographic survey and using drones for structural steel surveys in ports. In his free time, he teaches and he was involved in teaching machine learning and artificial intelligence to second-year BSc nautical students from IMU Kochi. May I request now Captain Ramji Krishnan to give a seafarer's perspective, I should say, on maritime autonomous surface ships and its implementation.
Yeah, I'll do that.
Thank you, Captain. Please.
Yeah, many thanks for having me here. Sincerely appreciated. And that was an excellent presentation made by our fellow panelists and presenters. I really enjoyed it. One of the few things which I'm going to avoid is going to talk too much of technology to technocrats, because I'm a navigator by profession and I'm also a manager by profession. So I'll talk a bit of a manager's viewpoint of how things work and also a captain's viewpoint of how things work. So probably I'm going to chart a slightly different course, much like Christopher Columbus. So I hope I don't land up in America instead of India. But then here are my few thoughts about how we can look at some of the things what we are discussing here, particularly as a prelude to scoping and what we need to do in mass. Some years back, about 3 decades back, there was a National Defense Secretary of United States, Donald Rumsfeld, who said something like, there are known knowns, there are known unknowns, there are unknown knowns, and there are unknown unknowns. Now I'll repeat it again slowly. There are known knowns, there are known unknowns, there are unknown knowns, and there are unknown unknowns. Okay. So what has that got to do with what we are discussing today? So basically, I'll just walk through very quickly through what are these known knowns. These are things that we know. And what we know is what we know. Okay. These are things that we know. Okay. These are basic principles and methods of AI and ML we saw today being discussed. We saw the existing applications and challenges in autonomous surface vessels. We saw that current regulations and standards that apply to them, the potential benefits and risks of introducing higher levels of autonomy in maritime operations. So as an example, we know that deep learning based marine object detection is a state-of-the-art approach for developing autonomous ship navigation, maritime surveillance, shipping management, and other intelligent transport system applications in the future. This was what we discussed today as well in the presentation. Now, there is a very nice thought which was brought in and a quote attributed to Mark Twain. It ain't what you don't know that gets you into trouble. It is what you know for sure that ain't so. Okay, I'll repeat Mark Twain's quote. It ain't what you don't know that gets you into trouble. It is what you know for sure that just ain't so. Now, why do I give that quote? The quote is basically because we have a tendency to predict the future based on what things we know and what we know, etc. Okay, today. There is a tendency on that. And this tendency is not just amongst us, it is among some of the big wigs, even from IBM president, for example, Thomas Watson, who reportedly said, I think there is a world market for about 5 computers. So for people who wonder whether mass is going to come into the future, when is it going to come into the future, it will never come into the future, there are various thought processes. This is a apt quote to remember. What are the known unknowns? Now, these are things that we know that we do not know. Okay. Let me repeat it again. These are things that we know that we do not know. What would that be? That would be specific technical details and performance of some AI and ML algorithms, the optimal design and configuration of autonomous surface vessels for different scenarios and environments, the future development and adoption of autonomous surface vessels in the maritime industry, and the social ethical implications of replacing human operators with autonomous systems. Now, as an example, we do not know how to ensure that autonomous surface vessels can operate safely and reliably in complex dynamic situations, such as collision avoidance, path planning, communication, coordination, human-machine interaction. There is also a question to a similar in the question box, okay, which touches upon this. Then there are unknown knowns. Now, what would that be? Now, these are things that we do not know that we know. Now, that would be strange, isn't it? I mean, it is the tacit knowledge and experience that human operators have acquired through years of practice and training in maritime operations. Okay. Then there are hidden assumptions and biases that influence decision-making and judgment in AI and ML development and application. There are latent errors and vulnerabilities that exist in our autonomous system and infrastructure. Then the unintended consequences and side effects that may arise from our actions and interventions. So as an example, we may not be aware of how human operators cope with uncertainty, ambiguity, stress, fatigue, or emergencies in maritime operations, or how they will be communicating or collaborating with other operators or stakeholders. So there is a challenge there. Okay. The last bit is the most challenging of all, and that really puts us back and makes us give us crazy predictions. These are unknown unknowns. What are unknown unknowns? These are things that we do not know that we do not know. Okay. These are new discoveries and innovations that may emerge from AI and ML research. There are new opportunities and challenges that may arise from autonomous surface vessels deployment and operations. These are the new regulations and standards that may be required or developed for autonomous surface vessels governance and management. And there are new risks and threats that may affect or caused by autonomous surface vessels. As an example, we do not know what kind of new technologies or capabilities may be developed for autonomous surface vessels in the future. That's what it was being highlighted today in the presentation. And what kind of new accidents or incidents may occur involving autonomous surface vessels. So what do we do in a world which is so opaque? What do we do? What can we do as human beings? So what is the way forward? Now, we have to remember before offering major predictions or major things that we have to also remember quite a few things. And these are the scientific discoveries happen in leaps, could happen in leaps. Okay? This is one major challenge in understanding the technology. And the technology, and it could also be serendipitous, meaning it could happen anytime. It may not follow the same process of research, because through serendipity, many of discoveries and inventions have happened. So what do we do now? So what we can do is, what is the way out is watch the pioneers in similar industries in marine transportation or basically in transportation. Let's say, for example, take the case of Tesla. Right? So when you take the case of Tesla and you start looking at what they are doing, and you start understanding that they are operating something like FSD. Okay, that is something which is, it's a full self-driving. And what they are offering is today a more or less a full self-driving on a car, which is going at maybe 100 miles per hour or whatever be it. How is he doing it? Today, FSD is probably installed in 600,000 cars, and he is doing a lot of simulation with those edge cases and trying to find out. Why do I talk only with just 600,000? But by end of next year, he will have those FSDs in more than 2 million cars. And that is going to need a huge amount of processing power, which is going to manage with Dojo, some different kind of computers, etc. So there are certain parallel industries which are using a different kind of technology and different kind of approach. For example, they don't use lidars or radars in Tesla. They use only computer vision. That is stereo cameras, which we talked about. Can we borrow those ideas? What can we borrow from them? What can we look at them? Is there something we can look and understand what is it they are doing differently from us? Because many people have solved some of those problems, probably. And maybe it is time for us to think through these various lenses which I put down. There's known knowns, known unknowns, unknown knowns, and unknown unknowns, and start asking ourselves major questions. Not just look at Tesla, but also look at other industries, how they are developing some things, like, for example, development in battery technology. If that were to succeed, for example, it is going to put out all the alternate fuels out of the window. So we have a huge challenge in front of us when we look at it, to understand how much of technology is being developed by various people. And these are the unknown unknowns, which are kind of worrying for me to understand technology. Because I'm no technocrat like you guys, but I do worry about these things. Thank you very much.
Thank you very much, Ramji sir. Now, can we check with Chary, sir? Dr. R Chary, could you come in for a... I think noted, sir. You should alternatively try probably with your laptop microphone instead of probably earphone. Yeah, please try with your laptop microphone instead of earphone. In the meanwhile, I'll introduce Anish, who is
Yeah.
another panelist from the industry. Yeah.
We just heard you, Dr. Chary. Just a second. Yeah.
Chary, sir, is it okay?
I
Is it coming in?
think some loose connection must be there then. We just heard you a little bit and then it stopped.
Can you hear me now?
Yes.
Yeah, yeah. Please come in, sir. That's fine. Very nice of you. Please come in, sir.
Am I the last person on the panel to speak?
No, but there is yet one more person. Yes.
Okay. Thank you
Of
very
course,
much.
we have, Mr. Dasgupta is still there. And I hope we'll also hear from today the technical secretary as well. Because I know they are all, working in this area for quite some time. So I request Dr. Chary, sir, for 5 minutes, if you could, initiate. Panel discussion.
Thank you. I thank INA for inviting me to be on this panel. Exactly about a year ago, I had given an elaborate talk on this very subject, covering most of the things which has already been said. So I'm not the last, maybe the last but one is also for luck, they say, because what all I wanted to say and didn't want to say has already been said. So it makes life very easy for me. The people who operate and run the ship, what is required is what to do, how to do, when to do under normal, abnormal, subnormal, and emergency conditions. Now, do we have any algorithms to cover all the tasks which are performed by the people who work on board, so that all those algorithms can be incorporated for a fully autonomous ship? If you ask me, I don't think anything exists. I'll give you an example, a simple example, because I have discussed this extensively with many of the operators of ship, owners of ships, who are a little bit concerned about it. They ask me a question, okay, everything is autonomous, there is nobody on board. Wonderful. The shipping company is going to save a lot of money on crew. Wonderful. The shareholders will get a lot of dividends. Excellent. But they say, suppose a ship develops a leak. Who will make the cement box to go and fix it? Does the autonomous ship have a provision for this? If there is a fire, maybe a fire in the engine room. Now, there are these automatic systems which can sense the fire, but which or what system or which algorithm will decide whether it has to be a CO2 that should be used, or a powder, or water, or what, or foam? Do we have an algorithm for that? You see, unfortunately, some time back, we had a ship which sailed out of Chennai. I was posted in Chennai, and it had a very young captain, and his family, who was on the family way, was signed off. And we just said goodbye to him. The ship went to Europe. In the Bay of Biscay, it developed a leak in the forward hold. Unfortunately, excepting for the captain, everybody was saved. In a situation like that, what sort of algorithm will enable the ship to be saved? So these are some of the operational aspects of the shipping operation that needs to be factored in when we design any system. I am a student of automation. I've done a lot of design before and after. The one thing that they always tell us, the philosophy is, every well-designed automation or automatic control system has a robust manual backup. even if you have the space, the space vehicles which go there, there is somebody at the ground station who is able to take up control. Now, in a fully autonomous ship, which is fully supported and controlled by the system itself, will this work in a shipping environment? I must congratulate all those people who have successfully run these 4 or 5 ships, but then they have been concentrating only on the situational awareness system, which talks about what is happening outside, sensing it and saying, here is the danger zone, so don't go there. The ship steers clear of it. But nobody has talked about what is happening inside the ship. So my question is, it's not a suggestion or an answer. My question is, so long as we are able to or unable to find a solution in the form of algorithms to enable the ship to carry out every function that a normal crew would carry out, till such time, I think we must have some kind of a manual backup, whether it is on board or ashore. Now somebody says the maximum amount of accidents took place, 80% of it, I don't know where they get the figure from, is because of human error. Now, if you're going to have a remote control station, some human is going to sit there. Will he not make the same error? Will he be better than the person on the spot? Probably one of the things which has not been factored in when this announcement was made that 80% of the accidents took place because of human error. It is not because of human error, just human error. It is because of the fatigue that people suffer on board. What has happened in the 70s and 80s? He had 60 to 70 people on board, but now it has come down to 2 digits, 10 and 20. So obviously it is affecting the person who is working on board. He works 4 hours, takes rest, come back. He has nobody to talk to. He has lost almost all contact with human beings. Could it not have been the reason for so many accidents taking place? So if you're going to have a fully autonomous ship, everything taken care of by itself, will there be no accidents? Will a remote control ship, because a human is controlling from there, will he not make a mistake? So these are all some of the things which have to be considered. What has happened so far? There was a survey, and in my presentation, I presented a survey that autonomous ships or MaaS is mostly being promoted by technology people who make technology, people who manufacture all this equipment. Now, if you ask me, there is nothing new. The situational awareness system which you're having on a ship has been there on these fighter aircraft long back. The algorithm that they use, like for example, the Kalman filter to identify the targets, it has been there for 70 years. It was taught to me when I was doing in my college. The Bellman equation based on partial microwave, I forget the name, Bellman equation, which tells you how to make a decision. It's been there for 70 years and it has been in use. So we are applying it for the first time on the ship. So already this work has already been done. There is nothing new about it. All that has happened, say for example, between 83 and 1983 and 1985, in Japan, they had started a project, how a ship can be controlled remotely by computers. So it is as old as that, but nothing could be done at that time because it was not the era of microprocessors. Even Intel 8080 had not been sort of stabilized. It was the era of IBM 370. So it was not possible, but the idea has always been there. So I don't say anything new. All these algorithms, they have been there for decades. All that has happened is the speed of the microprocessor, the fantastic speed of the number crunching capability has made it possible for all these algorithms to be implemented now. So when you implement these algorithms, you have to ensure, as far as ship is concerned, all the functions of the crew, whether it is on the deck side or on the engine side, should be the algorithm should be able to perform to make it a fully autonomous, safe ship. This is all that I have to say. Thank you.
Thank you very much, Dr. Chary. That has been a very nice thought about the risks that are there. Anyway, I'll be reserving my comments on this. I would like to now introduce our friend, Mr. Anish. He's founder member and team lead of Cochin Shipyard Strategic and Advanced Solutions. Cochin Shipyard is now making an autonomous ship, as I understand. So, and he is also a member of the R&D cell. Presently, he is pursuing indigenous maritime solutions in green energy, energy storage, unmanned network-centric solutions, platform-level integration services, and data analytics. He has a wide range of experience in system integration, integrated platform management system, ship data network, C4I, integrated bridge system, underwater sensors. He has more than 21 years of experience with the shipbuilding industry and 14 years plus experience in ship design and concept design, detail design, etc. He has already associated with 17 vessels testing and commissioning, and then he has worked for civilian vessels, naval, coast guard, and so many of the projects, including the aircraft carrier, he has been a active part of this. He says fast patrol vessel to Indian Coast Guard to aircraft carrier. And I now request Mr. Anish to bring in his opening remarks in the panel discussion. Mr. Anish, please come on.
Yeah. Thank you. Thank you for allowing me to participate in this August gathering. So I would be presenting a concept, or I would be presenting my views on the industry perspective on the maritime autonomous surface ships. The perspective what I would like to bring in as an industry is that first is that as the other panel members have indicated, one main point is the safety and risk reduction. So safety and risk reduction starts from the design perspective. How you are going to represent the design and how you are going to create, how you are going to generate the safety philosophy, how you are going to develop the technology development plan, how do you qualify those technology plans in the, so when you are developing a new platform, you actually define these things, whether it be an underwater vehicle or let it be a surface vehicle. The main concept what we should actually focus is on the definition of the platform and defining the and doing the risk analysis for the platform, do a proper safety philosophy with the specific modes of operation, including the how and robust the control system will be and how the control system will respond, how it will be available, how it will be fault tolerant, and what level of redundancies has to be handled, and how it will be compatible in the harsh maritime segment, and what are the major fault areas, or what can be the outcome of the doing a failure mode effect analysis on the platform definition, so that we really understand which are the operating mode, and based on the present understanding, what are the main failures or the cascaded failures and single point failures which can be avoided during the design. Second part is that how do we define the major components of an autonomous system? we start with sensors, where we have sensors like radar, we have lidar, we have cameras, and very specifically for doing precision path planning, precision navigation, we will require specific sensors like which uses a very high frequency radars or lidars, so that we take into consideration the dynamics or the sea state of the in which it operates. And finally, the thought process, what we have been from our experience in handling the autonomous ship, is that millimeter wave radars are more efficient and specific when compared with the lidars. And that is an area where we are now actively pursuing for the precision navigation. And for the general navigation, normal X-band radars and the navigation radars are suitable, which can be work in tandem with the proper electro-optic system. Now coming to the very critical part is the communication, which should work with the autonomous ship and the land or the remote control station. So typically we will start with a line of sight communication system for very close in range pilot vessel operations. But as we go beyond the line of sight, the typical strategies what are being presently talked about is of satellite communication. The biggest problem with the satellite communication is the latency and the jitter which is right now happening, and the bandwidth which is being offered by the in the Indian scenario. So this is an area from the industry perspective, what we could understand is that we don't have very dedicated satellites with bigger bandwidth to handle the real-time video or the we can handle the telemetry data, but we cannot handle the video signal or the live streaming signal directly through the satellite. We have to go with probably Inmarsat fleet broadband. But the biggest challenge with that is that the data centers are not presently in India, and the cyber security angle and the other aspects of national security, if we are going to propose a solution in the naval or the security segment. But if you are going for a commercial segment also, the another big challenge what I feel is from the cyber security angle. The cyber security, the biggest challenge is that if how do we do a proper air gap solution in the within the ship? That can be done by specifically creating because all the systems which are by hardening the operating system, typically the main integrated bridge system, ship data system, as well as the alarm monitoring or the IMCS SCADA system which is available on board. Typically the HMI is always run on a Windows-based solutions. The one also thing what we are trying to see is that can we have something like a headless system where the access to the HMIs is restricted, and secondly you can have systems which is based on Linux or a hardened OS, so that the people are unable to connect. And secondly, at the network level, we have a full stack cybersecurity solution running and constantly monitoring the packets which are going inside the ship to ensure that there is no false trigger or spurious signals are getting generated. Another big challenge which I feel from the industry perspective is that spoofing of the GNSS signal or the GPS signal. Because entire ship navigation right now works on GPS or GNSS based solution like GLONASS, or so there we will have to envisage a proper fail-safe signal which can be based on magnetic or other related systems, where which will ensure that if there is a spoofing scenario or where the entire system is getting, it is going through a denied area, then the commercial ship as well as the naval ship will have problems when we go it in the autonomous mode. This can also happen with the communication system. So defining the proper fallback arrangement systems in those scenarios are also a very critical situation. And another area when we talk about using AI and ML for because these AI and ML are very power hungry and resource hungry algorithms, which cannot be we have to typically go for a trade-off between the best implementation versus the computationally possible and energy efficient systems or energy aware computers on board. Because people have been telling more about this edge computing, but what happens with the edge computing is that it is you will require a multi-processor, system on a chip computers, which are very power hungry, and the entire energy which is carried by a ship, whether it is by hydrogen maybe in tomorrow or maybe by battery, is actually limited based on the conditions or the area which is available in the ship. So we have to have a next generation devices which are energy aware, so that whenever it is not in operation or whenever it is not in demand, the energy profile can be controlled through power management techniques, so that the entire operations can be streamlined. That is one area where a lot of research is going on. And that should also take into consideration the reliability aspect also, because you suddenly go on shutting down each thing, it should not so happen that the reliability of the system is put at risk. So there are a lot of trade-offs which we need to take into consideration when we create that safety plan for the ship. And another area we have to work is that there are a lot of non-standardization happening for the communication protocols, the navigation protocols, which is being propagated. So the development of the software as well as the hardware, if the standardization to a limit can be made, this is an area which can really help in one way the indigenization as well as interoperability from the Indian perspective. Because as we go from a normal semi-operated vessels to a fully autonomous vessel system, the availability of the hardware within the country, so that it is not having any malicious code, is very critical, even if it is a commercial as well as a defense ship. So this is what I just wanted to submit as the opening remark.
Thank you, Anish. That has been a very good view from the industry, and more of more than industry, a technocrat's view you are bringing out, and the pitfalls. That's very good. And you also brought out about autonomy is not simply autonomy of system. It is energy autonomy, navigation autonomy, communication autonomy. Different levels of autonomy has to be there. Now, can I request Technical Secretary, would you like to come in, Dr. Bharadwaj Srinivasan? A minute or two. Your microphone is off.
Thank you, sir. From purely say maybe a research perspective, I would just like to add a few comments from the research perspective. Basically, when we talk about research, we talk in terms of technology readiness levels, and with respect to autonomous ships, a few technologies in terms of probably hydrodynamics and controls, navigation, we may be probably at a level of 6 to 8, where probably we may be having industry-ready algorithms. But when it comes to sensors and sensor fusion, we are somewhere around 4, where we are able to prove that in lab prototypes, and very interesting experiments are happening in the country. The safety is a very important consideration. And right now, what we are attempting is that when we operate autonomous systems, the autonomous systems should not harm the existing human systems to start with. And as we progress, we think, if I can paraphrase Asimov's robotic laws, the first law is certainly to be followed so that it doesn't injure any manned systems, or it doesn't interfere with the manned operations, particularly in harbors. And later on, we go and see how the technology is progressing. Particularly when we get more and more data on operational scenarios, we hope that will probably be one of either the unknown knowns or the unknown unknowns, that as and when we get more data, our self-learning algorithms will be mature enough to handle more and more situations which are expected. Localization is an important problem, both in the relative and the absolute sense, which was already told by Mr. Anish also. Because localization, and particularly when different sensors are not able to visualize in terms of foggy weather or high sea states, when the sensor stabilization becomes an important factor, localization will get affected. And so these are all some of the areas which finally, are entering into the safety and of the autonomous systems itself. With this, the final remark I'd make is it is about the link between perception and action. Both these technologies are somewhere at a technology readiness level, even globally at around 4 or 5, with a few technologies even at 2. And as we go, both the perception and action technologies will improve. And hopefully we'll be seeing it in the coming decade that autonomous ships will be more and more going to the level from level 1 to probably level 3 or 4 with a decade. This is the perspective from the research.
Thank you, Bhagat. Now, may I request our President, Dasgupta sir, to give us his perspective view and what we could do as a professional body, how much we can support this system.
I thought my turn would come in the end, but you have put me in a fix.
Sir, so you are in the beginning and the middle and at the end.
No, it's okay. There are a lot of interesting questions which are there. Yeah. So I think those questions also need to be looked into. First of all, let me just give you the idea why we chose this topic for discussion. This discussion and work on marine autonomous surface ships have been going on for the past few years at IMO. We have not been privy to that participation. We were not participating. It's only at the Maritime Safety Committee MSC 107 that we could attend those partly physically and mostly online. So it opened up a few thoughts in my mind, and I felt that we are at a very critical juncture in the maritime industry. On one side, there is this autonomous vessels proposal, a lot of work being carried out and being passed on to us. And on the other side, there is this decarbonization on which we have been working for quite some time, and a whole lot of people know about it. So we thought of organizing this session and try to see as to what extent we can get the different perspectives from all the people who are working on it, have worked on it, and have a good say on this. On this matter, we are indebted to Dr. Chary because he made a presentation last year, but that was on an autonomous ship without really knowing what are the regulatory perspective and what is being looked at. So let me give my perspectives here on this. Number one is we are talking about a goal-based standard, which means that it is a goal-based, non-prescriptive standard as of now that is being evolved. And so when we talk about goal-based standard or any kind of a standard of this kind, we need to balance between two different aspects. One is that of principles, and the second is that of rules. Principles means as a ship, the ship has to float. She should not capsize. She should be able to propel on her own with or without, in this case, without effective support of human beings. And then she should be able to steer clear of all dangers and so on and so forth. And on the rules point of view, it should be, number one, safe. It should not it should not create trouble for others. It should be able to interface with the port and with the other ships en voyage. So these are the rules part of it. So that these rules and principles, they need to be separated out. During the I was a part of the team which were speaking online, attending online, and I did raise some of these points with the working group on Mars, and they thought about it, and the chairman was kind enough to acknowledge that these are the issues which need to be looked into. So there are many things which we know. First, let me compliment Captain Ramji in your immutable, in your typical style. You have addressed all the aspects: known knowns, known unknowns, unknown knowns, and unknown unknowns. And definitely, unknown unknowns are the issues which we don't really can do anything about. And in essence, in the past, in the history of human society, we have addressed it through inductive logic and through mathematics. So I would think the unknown unknowns can only be addressed through that process. There is no other way we can address unknown unknowns. On the issue of the known aspects, Dr. Chary has again elaborated all the issues. From what he has talked about, two thoughts come to my mind. That is, how to cover the insurance, whether these vessels can be insured, and to what extent, what will be the the idea of the insurers for these vessels. And second is human interaction. And here, a lot of work has already gone in on the human reliability aspect and human reliability index. A huge amount of work has gone in the other industries, which are not shipping. So automated systems in various other industries have already addressed the human and machine interface, HNI, as Mr. Geda has given. I forgot to acknowledge Bhagat Singh Geda. You have made a very, very nice presentation. I really appreciated the presentation and the perspective from which you have made this presentation. Congratulations to you. With regards to Mr. Anish, you have given the industry perspective, and which actually addresses what is known. What all things are known. And from that perspective, the what is being done in India, I can give you a little idea about what is being done in the parallel sector. You have all possibly have heard of CDAC located in Pune. CDAC Pune is making computer systems which are of the order of 15 to 18 petaflops. That is, our normal i7 engine, which is 8-core, and the total number of petaflops which can be there is flops is of the order of about 36 gigaflops. So from giga to tera to petaflops. So in terms of real-time intervention, if required, India does have the systems and the research projects which are developed and which are being pursued, which go into that domain of real-time intervention. The second point, Anish, if I may come in here, there are two aspects to it. One is something to do with your own health, the ship's health. And ship's health has to be monitored and looked into, and that there is IoT for that. IoT is there for ship's own health system. And that possibly will be able to address this aspect. This is my opinion, possibly unknown and completely childish, but at the same time, robotics and IoT can possibly address this aspect. And second part is with regard to cybersecurity and artificial intelligence and machine learning, energy requirement, those aspects, of course, will remain. And that is an integration of the energy management and the decarbonization and all those aspects which are coming in together. So I'm not going to say anything on Dr. VBS's comments. I think he knows much more than what he shared here. So I leave it at that. And thank you very much for giving me a chance to give my comments at this stage. There are lots of questions I repeat which are there and which need to be addressed. And lastly, Dr. Korulla, I understand you know a lot about this, so you can educate the audience. Thank you so much.
And thank you, Dasgupta sir. That has been really wonderful. You have also looked at the topics that were discussed. So I don't want to attempt that now. We could straight away get to the questions, or how do we go about? Shall we look at the questions, some of the questions, and then we can come back?
We can look at the questions, sir, then we can have your comments.
Yeah.
If it's okay with you, sir. So perhaps we can take the question from Mr. Abdul Rashid. High-risk areas and some traffic risk-rich areas, such as Malacca Strait, what precautions this mast is going to take over? This is his question. So perhaps just request whether class
panelists.
Yes.
Anybody who can come up?
Yes.
Captain Ramji, please answer.
Yeah, see, I can give an analogy. What is happening in another industry? As I said, the easiest way to understand what people are doing or what can happen or what should be the way, as I said, unknown, is to look at some other industries which have similar problems. And one is in car industry with what Tesla is doing. And how they are going about it is, of course, will be slightly different from what we need to do. So how they are going about it is, of course, having a FSD installed in all cars and having a lot of simulations done on edge cases and having a lot of things being ironed out through automation and autonomous driving. To the extent that today you can drive a car from New York to Austin without much interference, probably 1 or 2 times you will need to intervene to take care of things. So to that extent, the technology has already come up. What do we see in this kind of a case wherein we need to have a, what do you say in Malacca Strait, what do you do? See, we basically track all of these ships through satellites. Okay, we have all of them, all of the AIS things are there. And plus, it doesn't stop us from installing some, what we call in critical areas, nothing stops us from installing VTS systems so that we can monitor it again, twice over. And the third is, of course, as I mentioned, when you look at other industries which are using, they are not using just relying on radar and whatever it is, they are also using computer vision and through very low cost cameras. Okay, so there is a mixture of, as Mr. Geda pointed out, an amalgamation of all the sensors and to figure out what is the position of each ship. And it is pretty easy to track what is going on each of the ships. The thought process that we need to remote control this may need a bit of revision probably when the unknown unknowns become more and more clearer. Because in Tesla cars today, they are not remotely controlled. Okay, each car can navigate on its own without being remotely controlled. So the thought process of having a remote control, then we bring in the problems of cyber security, then we bring in the problem of latency, then the bringing of problem of connectivity may not be need to be figured out. Okay, need not work on those kind of things. So there are many ways of resolving the problem. A simplest way would be a VTS and this one. So it gives you and it doesn't cost you too much to put up VTS. So you just need to identify high critical areas of traffic areas wherever you need a VTS, put in the traffic separation schemes as well, and also the radar monitoring system. I think you would solve a significant percentage of the problems of this. I hope I am answering the question.
Yes, sir. We can go ahead with the next questions and comment by Mr.
Sir, Sir, I would like to add some point more to what Captain Sir has indicated. The another easiest method of doing this is to have a really because this is going to be a purely on a very high traffic area. So using computer vision and using things may be very complex, because what happens is that you need to have a mathematically modeled or in a computationally possible mathematically modeled control system is required, or else our ship will not respond to these kind of very fast action, and it will have its own hydrodynamic coefficients which will not able to properly support it. So probably what we can have is that is a combination of using the remote control, using satellites based communication is one option, or probably because the camera streaming may be a big issue because considering the latency period, but telemetry it is always possible, and it is possible with some edge computing happening on the computer on board the ship with a potentially computationally possible system. That is the more critical word I was trying to say, because the biggest challenge what we have right now is that if you are using a very power hungry device on the ship, this will have a huge impact on the complete endurance of the ship. So we need to have a very specific power optimized systems on board. Then only these kind of areas we can address properly for a longer endurance.
Just
Okay,
to add
that's
to,
good. Yeah, please.
just to add a quick comment, sir. When it comes to specific geographical areas like Malacca Straits, the path planning can effectively be done by the use of ENC charts, which are already available for very specific geographic areas, even at finer grid levels. With finer grid levels, that will be basically addressing the known obstacles. The rest is coming to traffic management, which both the other panelists have told about the difficulty in addressing the traffic management. So when it comes to specific areas, the problem itself is split into two parts. One is addressing the regular obstacle boundaries by using ENC charts, and the second is the traffic management, which is basically requiring navigational sensors and others to recognize the obstacle and having an effective obstacle avoidance algorithm. One advantage we have in such cases is that we can always have ground board station within line of sight where high communication bandwidth is possible when we have a specific geographical area in mind. But in a more open sea, it's one advantage is the traffic is less, so is the communication and the latency efforts. So that's where it is. That's where it is.
Very good, Bharat. I just wanted to add.
Sir, you're on mute, sir. You can just unmute yourself.
Okay, I'm very happy that very good discussion is happening. Very good. I just wanted to add, it's very good, but the points where Malacca Strait and such traffic congested places, what we are doing at traffic junctions, that also may have to be done. Without traffic police, how we are managing vehicle, you have to have a post there, you have to have signals. So such places, it is not only the vessel, the system itself, you should have signals which are intelligent, and they should be giving, it is a multiple system. So there has to be a sort of a system which will be controlling the traffic there, and that system has to be interacting with the ships. So this is the system that has to be there. I agree with the point that has been brought in by Ramji Krishnan sir, as well as both Anish and Dr. Iyengar. So there is something called simultaneous localization and mapping, SLAM. So this is not only by getting the things that are stationary and which is existing, you can have an active system also incorporated in simultaneous localization and mapping. And that may have to be introduced at such critical points. This is what Bharadwaj was also telling, like ENC chart and other things. You have to engage systems, special intelligence system, should be getting engaged with the autonomous ship. Okay, can we go to the next question, please?
So Mr. Subedar has commented a question is in the panel. I would just request Mr. Surveyor to post his question, which is already posted. Please, sir. I'll just read out his question as he's joining. He wished us good afternoon, and at and before the next STCW subcommittee and MSc, Indian position is made clear at IMO by nautical advisor of the Government of India. DGS position on mast level and 1 and 2 notwithstanding, new or comprehensive review of STCW. This is a comment. And
okay,
another comment.
That's okay. Then you see, we have almost 12 to 13 questions.
Yeah.
The comments, reading out will be good, and
Yes,
we'll all, if we have some comments, panelists, can bring out those comments.
Yes.
Can we read out few more questions?
Yes, sir.
And then probably we'll answer together for a few more questions. Yeah.
Yes, sir. Another comment is the non-mandatory code in making may please be circulated by INA or the panel to CMMI, IMEI, etc. for a comprehensive relook at the text that could be taken to ISWG soon as possible.
This could be noted. Actually, this could be noted by the concerned. Next.
Mr. Kamal Palit can join us. He has thanked Dr. Chary, and it's an interesting topic, autonomous ships.
Kamal sir. Palit sir, please.
Please, sir. You can just put your question, sir. Palit sir, you had this thing. You have really contributed about Dr. Chary. He was just asking, will you kindly inform how we can generate fresh water, not by freshwater generator, but from solar energy? That is one question. And another question to any one of the panelists is about sail-assisted sailing ships to save crude oil for climate change, which is now a global requirement. These are the two questions.
There is another question to Dr. Iyengar. Can autonomous pilot boat without a pilot? That's possible. That is actually pre-programmed system.
Pre-programmed system with, as I was telling, with specific GNC charts for a specific harbor and very detailed this thing. Can be done with line of sight at level 1 and level 2 autonomy. The human factors have to be considered when you're doing level 1, level 2 autonomy. But yes, technology is available up to level 2 to do this.
Next question.
Yes. Now, I would like to, Professor Ajit Shenoy has come in, and he's complimenting and thanking the speakers and the panelists for outlining and explaining the mass in clear and simple terms. Okay. He has two-fold questions.
Yeah.
What is the state of readiness of Indian maritime industry? There is a builders, equipment suppliers, software houses, operators, and academia in embracing this new category of autonomous vessels.
I think that is a big answer that is required, and everybody will have opinion. We will take 119 opinion at the end of all the questions. You can read out other questions also. We will definitely answer to Shenoy sir. The panelist 1 sentence will be answering at the end of it. You can finish the questions.
Yes, sir. And what steps are being undertaken by the Indian maritime industry to collaborate with industry in airborne drones and automotive sectors?
Yeah.
The next question is by Mr. Srijesh Sivan. What is the role of IoT in the operation of autonomous ships? As we have recently witnessed the use of computer vision in fishing trawlers, but not for navigation, but for identification and categorization of the catch. As discussed earlier by earlier panelists, do we see any development in the academia towards utilization of neural networks, quants, and other algorithms in the development of autonomous ships? There's a very specific question by Mr. Keith Miranda. How does MAS handle wind force 12 with 10 to 14 meter waves in North Atlantic winter? We have a question by, and another question is, how is MAS obligated in a rescue at sea situation? These are two questions by Mr. Miranda. Then Mr. Maka has asked, for class, how will you certify an AI/ML based perception system for the future? Will it be certifying the data sets collected by the companies? How will confidentiality be handled? Will you certify the final AI/ML model that will be used on board? How will you address the fast-paced iteration that in model deployment then? Class certifies certain things like DP systems, autonomous vessels essentially use more advanced controller to do trajectory tracking. Do you have any plans to certify the same? In case of accidents, who will be responsible? Particularly in the Indian Navy scenarios, where the autonomous software is developed by the firm, but the remote master of the vessel is likely to be an Indian Navy officer. How will the rules differ based on vessel length, speed, and displacement?
This is an exhaustive question.
Yeah.
Definitely, the panelists will give one line answer, and we can address these questions. We can give you, basically, we request the people who are listening. These are really thought-provoking questions. And of course, there are answers for this. Few answers, because we were working on, almost last 25 years in this area, 25 years from more than 25, 92 onwards. So we have answers for this, don't worry. But this can be discussed. Can we finish the questions further?
Yes, yes. One question, and it was already answered by one of the other audience. What about cargo operations in MAS? It was answered as already a port-started cargo operation, totally unmanned, including the truck. And the answer was given by Mr. Abdul Rashid. And Mr. Sushil Ban has asked, what is the plan if a MAS ship experiences mid-ocean breakdown? These are different questions, sir, as of now. So now the chair can advise us how to.
Basically, what I am hoping is that we will request the panelists for a 1 minute, response the questions vis-a-vis whatever areas they have. 1 to 2 minutes response from the panelist. So I would like to start with Captain Ramji Krishnan.
Yeah, many thanks. I'll start with the last question, then go up whichever is related to navigation very quickly. What is the plan if MAS ship experience mid-ocean breakdown? And you have to remember some things in MAS that, as the presenter pointed out, there are 4 levels, and we are not going to be level 4 tomorrow. So it is a step-by-step process. Okay. So we have go to level 1, level 2, and level 3, and we learn as we go forward how to avoid a breakdown. So then only we are going to be in level 4, and we are not going to get level 4 tomorrow and do it. And it is not possible to do it that easily as well. So that is hopefully is an answer to you. And the other one is basically, how is MAS obligated in a rescue at sea situation? I guess that question will only crop up if all vessels are MAS level 4, then there is no issue. But if there is going to be an issue, that you have a very valid question, which is going to be again tackled in ways of regulation. So to be honest, as on date, I do not have any answer to it. If you are a level 4 vessel and if you see a fishing vessel nearby, what happens if there is a rescue situation? I really do not have the answer. Then all those things where the rules are, again, as I said, the rules are going to be developed as we go forward, okay, step by step. And each of these rules and accidents, who will be responsible, who will pay out, who will be the insurer, will the insurer be willing to do all will be addressed. As I said, we are not into level 4 for at least we have some time to go there, and it will be handled slowly but surely as we go forward. So then what else is there? And will we set it in database? How will confidentiality be handled? Wind force 12, how will you handle? By avoiding it. So that's what more often than not will happen, because the mass vessel in all probability is not going to get into that easily. So can autonomous pilot boat without a pilot? Yes, it is possible to do that. Or possible today? Sorry.
No, it is possible. It is possible.
Yeah, it is possible, but it will be done one fine day, because it's a work in progress, which which will take place.
Yeah.
Role of IoT operations in autonomous ships. Well, good question. If you really think about it, there's one thing which I want to deviate, slightly digress and take it up. Is one of the challenges which people have not really been addressing is, are we going to continue with IC engines and also incorporate autonomous? I don't believe that is going to happen that easily, because IC engines, as we all know, is fairly complicated. So my suspicion is my personal take. I have to look up the research. Is like there will be an alternative thing like an EV or a fuel cell or whatever be it, and there are some things pretty close to it. If you want to know more about it, one area where you can look up is Bloom Energy's sale of fuel cell technology to Samsung. And Samsung has already got a DNV approval for having a LNG-driven fuel cell, and the fuel cell will generate electricity, which means everything on board will be electric, which means all your complications regarding measuring which machinery is going to work, not work, of IoT, etc., may come down dramatically. That is what I personally think. That is, again, it is an area of unknown. Okay. So that's why
actually, very correctly said, Professor Dr. Ramji. Actually, what we should have is an artificial stomach. Whenever you want to eat, you can eat, and whenever the energy is required, it will take off. So the research has to be on that, and once it is ready, probably that may be the solution. The hydrogen fuel system, what is being thought of, is something similar to this. Whenever you want to consume, you will be given the amount that is required, and balance will be stored, and when you can use. So this, I think, is it's very much possible, and it is all going to happen. Okay, can we request now Chary, Dr. R Chary, could you come in and 1 or 2 minutes, sir? Could you respond?
Yeah. The last question: what will happen if the ship breaks down in the middle of the Pacific Ocean, fully autonomous ship? That is answered with the example of Mayflower 400. It set sail last June from UK to USA to commemorate the 400th anniversary of the sail across Atlantic. As the ship failed, it's a research vessel. It failed because of a mechanical failure. This is what I am, in my opinion, I said that you should have some sort of a help on board. The ship failed and it had to be towed ashore back to UK to be repaired and set again. So this is the answer. It will have to be towed. There is no other way right now. And the other one regarding training, was it, which the previous person asked? Was it about training? The last two questions.
So the last question, I apologize. Apologies, sir. The last question was basically, I just missed out. My apologies to Mr. Sawarkar. He was asking about the exact role and basis of acceptance by regulatory bodies. About training, there was not a comment, sir, but you can make a comment on the trainings if you want.
Training.
Yes, sir. Yes.
You see, we have in this country, we have multiple schemes of training, alternative AIS, they call it. You have the degree level, you have the workshop training, we have all the other kinds of training. So making a uniform curriculum and syllabus is going to be a Herculean task, because particularly when you take the situational awareness system, the kind of electronics that is going into it, a person who is just coming from a workshop training and goes for certification, it will be very difficult to train him. So you have to find a common ground for what sort of common curriculum and syllabus you should have to train a person who has just got a 12th standard qualification, and another at the other end who is a graduate marine engineer. So that is going to be a difficult task. One of our PhD scholars is working on it. He has also come out with a curriculum, but it has to be seen how we are going to implement it. It's going to be pretty difficult, because you can have somebody who goes to a workshop, gets a certification, goes on board. His level of preparedness will be much lower than a person who does a BTech marine engineering, where quite an amount of electronics is there. Even for BSc Nautical Science, there's quite an amount of mathematics is there, quite an amount of electronics is there. So it is going to be a tricky issue, and how the authorities will handle it, it's anybody's guess.
Thank you, sir. Thank you. That has been good, quite good. Now, can I request Anish to respond for 1 or 2 minutes?
Yes, sir. Sir, I'd like to talk about the certification of AI and ML based perception systems. See what is going on, and there is a query asking, will the class be certifying the data sets, or how the confidentiality will be handled? See, as far as from my personal experience in the AML space, we will be looking specifically for the performance aspect of it rather than on the data sets and how the algorithm is going to work, because it will not be practically possible to go through the entire data set, understand each data element and how it is getting properly attributed and other thing. That I believe will not be the responsibility, or that should not be the way in which it has to be handled. And fundamentally, we will have to create a lot of test scenarios where it is performing with a reasonable level of accuracies and a reasonable level of repeatability. Then I believe the entire solution will suits the application. That is my perspective. And second point is that whether we will use specifically ALML techniques, because ALML techniques, even if you wanted to ask, it has to be have a low footprint as far as finally for the implementation is required. So there also we will be using a trained AML solution with the lowest footprint on board. So I believe that will be an area where a class will get involved rather than on the design aspect. And secondly, another area what I personally wanted to also have a talk is that what is the role of IoT in the operations of autonomous shipping? See, as our chair as well as the Captain sir has indicated that these are going to be EV or a next generation kind of a thing. So specifically already the SCADA solution as well as the DCS solution is already on board. So this will have to get miniaturized and it will become more decentralized and very specific health monitoring and specifically from the flood and fire detection has to still be made available there to ensure that we are properly assessing the system, and we are in a mostly all the scenarios what we are going to have is going to be a deterministic kind of a scenario with extremely unpredictable scenarios can be still non-deterministic. But I personally believe those areas we can still go with the traditional things rather than going for edge computing, because we need to have energy aware edge computing. That's all.
Thank you. That has been wonderful. I think we have fairly addressed all the questions well, but still more are there. There is one question that has come now. I had this is from Abubakar sir. This question he should have been answering this question actually. I had put forward a question before that. What is the exact role and basis of acceptance by regulatory bodies. Anyway, this answer probably we can expect from him. I know that he is well aware of the answer. Regulatory bodies, they have a lot of role to play. It is in the development stage. It is a chicken and egg story, whether the rules and regulations should be first or the actual system should be first. So it has to go hand in hand, parallel, and otherwise it will not happen. You are well aware of this, sir. I'm sure that a lot of work is going on. Only, Mr. Ajib Vasudevan of IMO, he has, continuously persuading me that India has to play a major role in bringing about the rules and regulations. Otherwise, somebody else will put it on you. This is what is, that is the message that is coming. International community, we are a part of it, and you should take active role in this. Otherwise, they will put all the rules and regulations on your shoulder, which you will not be a party to it. So, Dasgupta sir, as he has said, our part we have to play. If you allow somebody else to play our part, they will be ruling us throughout. So, the effort that is being put in by individuals, there is a reason to come together, there is a reason to collate, and there is a reason to represent the country in the international scenario at the appropriate forum. I think this is what is my answer for Abubakar sir. He has brought this question correctly. Regulatory system, we are a party to it. Acceptance system, we are a party to it. We should be able to define this. And we are not very late, but I had to say sorry to Ajib Vasudevan. I had mentioned that last year itself we will be sending a team. But of course, I thank those who have attended, those who have, Dasgupta sir has taken a lot of initiative. But that's not enough. We have to have a 10-fold, 20-fold more increased presence in this international forum. Whatever has to be, today's greatest achievement will be that if we are able to bring in some understanding about how we should represent ourselves in the international fora, that will make the next few years, smoother for us. Anyway, with that answer, if you all permit, I would like to, we have just 10 minutes past 6 o'clock. We should have been finishing, but the topic was so interesting. We are proactive. And we have moved a little bit. But I should say it is such a wonderful session we had today. And the whole thing was mooted by Bhagat Singh Geda Saab and Commander Sandeep Kumar. They have given an outstanding overview about systems, technologies, rules, and regulations, and how the whole thing has come about. And they have beautifully designed what is an autonomous ship. I was just trying to pick up it. It is a surface ship that has a mission control that is pre-programmed or adaptive in real time, with minimum or no supervisory control. And they are divided into 5 categories. We have to go one by one as we implement it. And probably we may be able to reach the 5th. And they have brought out what are the risks, who are the stakeholders, how it has to be addressed. I really appreciate within a short span of time, the permitted time that has been given to them, they have drawn a beautiful picture, which is going to give us an overall idea about how are the things shaping up and how we should be reacting to it. Wonderful. We all appreciate you. You can raise hands to appreciate him, the team. Please keep continuing your good work. Yeah, that's great. That's great. And then, I should say that we could pray. I mean, today we could give homage to Govil sir. Sawarkar sir by Govil sir and others. Mr. Simon also has joined. I appreciate them. Later, we had this panel discussion. I should say all the panel members, they are, very much deep into autonomous systems, and they were knowing ins and outs. I know we could bring in only a mini school of their knowledge, and we could taste it. that we have solutions for all the questions that is coming from the autonomous world. I only felt that somebody should be, in the defense sector. I understand that there is a renewed interest and a lot of work is going on, but that cannot be published, that cannot be put into civilian sector straight away. In a ship or a submarine, we know that thousands and thousands of subsystems are there. 100 and technologies newly getting developed. Each time a new system is being made. And the industry has to be coming up for taking all these technologies. DRDO, I know that there are so many labs together. They are developing autonomous systems for last so many years. All the weapon systems are autonomous, almost all. And all this knowledge, all this industry background that has been put in, that has to be brought together. All the panel members were finally bringing out the knowledge base that is required India has. It is that somebody has to sit and bring them together to have a meaningful autonomous sea systems development program for India in all respects. I know that, Cochin Shipyard is taking a lead. Other shipyards are also looking at it. Industry, many of them are making small autonomous ship. But as a country, we have to move forward. We have to be a party in making decisions about how the autonomous system has to trend, the rules of the road. The country has to make an active role in deciding all these things. All the panels were bringing out this. As far as Ramji Krishnan sir is concerned, he has told us all seafarers' perspective, what one should be looking at. He was looking at all the details of uncertainties that are there and how we have to look at the uncertainties. As such, the sea is uncertain. So the vessel that we are making also is not predictable, unpredictable. As sea is unpredictable and the vessel is unpredictable, then you need not operate anything. So anyway, sea cannot be made predictable. It will go its own way. Only we have to look at what it is and respond. And our system should be as predictable as possible. So he has well brought out the situation. And then Dr. R Chary, he is a master of the game. He has looked at the risk and he has said that risks are there, but we have to solve it. Everywhere risk is there. And human error, he has told, it is 85% of the accidents are due to human error. But that human error is, how that human error has happened, that also he brought out. And how in this particular situation, how we can make the accidents to a minimum. He has really well delved into that. He also told, what are the knowns, what are the unknowns. Captain Ramji sir was bringing about knowns and unknowns. All the panelists slowly has brought in actually what is known and what is unknown in this area. That's quite interesting. And areas of, I should say, the areas of danger, areas of fatigue, areas of uncertainty. The sea is that. And, there at least you are taking man out of that areas of danger, areas of fatigue and uncertainty. That is the minimum thing that an autonomous vessel does. Anyway, another point what Dr. R Chary has said, the idea of autonomous vessels has been promoted by people who are developing technology. And the rules and regulations also they will be developing. Are we a party to it? We should say yes. Otherwise, we'll be out of the game. We'll be slaves. Next is Anish. He has brought about the technology perspective and how the industry is responding. What is the possibilities? What is, best? What is good? What is bad? Identifying it is based on the actual role it has to play. Even about the computer systems, the memories, the system, everything, we should have an understanding about it, and it should be looking from the view of the actual use. When taking a system which is having all dashing philosophies and specifications. What is aptly required, whether LIDAR is required or radar is required, he was telling about microwave radar, which is preferred over LIDAR. So this sort of an understanding, when you make a specification, we should have. It should be the purpose for which it is made. Objectivity should be there. That objectivity should be coming into the autonomous sea vehicle system development program. It should be on somebody else will tell this is what is required for the vehicle. The designer should have a feel of what is required for that. We should grow, into that, like Tagore has said, into that heaven of freedom, let my country awake. We should say, into that level of understanding, let our country awake, that we'll have autonomous vessels. Now, Bharadwaj has brought out the research perspective. He has been, I know he's working for the last 25 years. PhD is also in that area, autonomous vehicles. So what he said is correct. Technology readiness level, we should have an understanding. And what level we should be growing. There has to be a way of measuring our technology growth, and we should see whether we have to accelerate it. And what are the other things, infrastructure and other policy making, the political will that is required. All these things has to be brought in together, so that a synergic collaboration can take us into the world market of autonomous sea vehicles. I need not brief what Mr. Dasgupta said, because he'll have the last word. So he'll be briefing on that. But he has told, he has appreciated all the panelists' views today, whatever you have brought in. He has said the rule-based system, like ship should be taken as a platform, as such, which will float, move, and act. And then you should look at, for moving and acting, it should be having safety. And then, you should have a coexistence and sustainable system with other systems. When it interacts with other systems, it should not perish. It should not trouble others. So he has said that when you are making an autonomous ship, it is not one ship. It is the total ecosystem that has to be geared up for this. And that each and every ecosystem that may edge out something. I should not say this. Whether do we have seafarers taken out from the system? They have to sit on the port and do the thing. That will never happen. They'll have their role. So are we going to edge out anybody? So this is what he has said. That is the, the total vision he was bringing about. I appreciate you, sir, for this. With that, probably, I should say overall, it has been a mind-blowing, day for autonomous ships development program in the country. I am sure all of you will vouch for it, and we'll all have to bring in a change, a paradigm shift in the way we think about sea systems. Thank you very much. I request Dasgupta sir to have the last word, and thereafter back to VPS Iyengar, our technical secretary.
Oh. Thank you very much. Thank you very much, Dr. Korulla. I'm not having the last word. I just want to raise my hand to give a chance to Commander Sandeep Kumar and Mr. Geda, Bhagat Singh Geda, to say a few words about what they would think on some of the questions which were posed, if they would like to say anything on that. So that was the reason why I raised my hand. It was a wonderful session. I think what we aimed to do, to achieve, we have achieved today. I think broadly the audience have an essence of what an autonomous, marine autonomous surface ship is going to be, or in terms of the goal-based rule development, what is being aimed at. There are a lot of questions remain unanswered and are in the process of getting kind of developed or answered. So with that, I would request Dr. VPS Iyengar to give the vote of thanks. Thank you so much. Thank you so much, everyone.
Thank you, sir. It was a very interesting and long session, and some of the questions, though not directly answered, I hope there are some hints of the answers in various perspectives. Today's session was very lively, and first thanks to the speakers, Mr. Bhagat Singh Geda and Sandeep Singh, to have set the foundation for today's discussion, and the panelists, Dr. Chary, Captain Ramji, Krishnan, and Mr. Anish. And my big thanks to the session chair, Dr. Manu, who has conducted the session in a very lively and very professional way, and tried to address all the questions and queries, as well as commented on various panels. Because this being an evolving topic, some of the questions are still unanswered or answers are evolving, and we'll have to wait for the future session, maybe 1 year down the line, to answer some of these questions. So thanks to the chair, the speakers, and the panelists. And also today was a well-attended session. We had more than 60 people attending the session throughout the webinar, which is perhaps the highest this year in a live session. So we thank all the audience to have attended in large numbers. And my thanks to Dasgupta sir and Amir, who have, as an advisor, he's always supported us, and Amir, who's in the background, and ensuring that this session went seamlessly. And the INA office, whereas Sylvie and all, who ensured that this session went seamlessly with all the communications, the webinar, and the technology. Thank you, sir. Thank you all. And with the permission of the chair, we can close the session.
Thank you.
Thank you.